Hello everyone, welcome to my Physics 101 lab project presentation. In this project, I wanted to examine the period of simple pendulum and its relation with string length, mass, and gravitational acceleration. Theoretically, once set free from an initial angle theta 0, a simple pendulum will undergo a periodic motion. Understanding this motion and solving for the period would require one to solve the following differential equation. Unfortunately, this differential equation is kind of hard to solve, and in order to simplify things a bit, one can use what's called small angular approximation and obtain the following result. Since the error introduced by this approximation is comparatively meaningless to those of the environmental factors and calibration and so on, we will use this approximation in order to obtain the theoretical results. Objective of this experiment is to better understand the motion of simple pendulum and mechanics behind it, while also testing the validity of our theoretical results. Let me quickly walk you over the equipment I used in order to perform this experiment. So here's the setup I used to perform my experiments. Here are the measurements I made for the quantities, mass and length of the string. I didn't measure gravitational acceleration directly, but I used the inclination constants given in the blocks in order to obtain the effective gravitational acceleration. So let me quickly digress into my data analysis method. I used the slow-mo capture of the experiments in order to obtain the data about the periods. To be able to take random errors and systematics into account by their own, I used a box and whisker plot, which both illustrates the mean of my measurements and the deviance in that measurement by statistical methods. So as you can see, some of the data concentrates on a mean which is quite similar to the theoretical value, and the difference between the theoretical value and the experimental median can be easily explained by environmental factors and small calibration issues. And also you will see a distribution around that point, which shows how random errors affect single measurements. I also included an analysis of the random errors and systematic errors that might have been the cause of the difference between expected and measured values of the period. Thank you for listening and have a great one.